The product that I chose to analyze for this project is nail polish remover. I read the label for nail polish remover, and the three compounds that I chose to look more into are acetone, butyl acetate, and glycerin. To start, one essential compound that can be found in nail polish remover is acetone. The IUPAC name for this compound is propanone. The structure of this compound is fairly simple. It comprises of 3 carbons linked together to form the parent chain. This chain is formed in an alkane. A ketone functional group can be found on the second carbon. Thus, the prefix prop comes from the 3 carbons and the suffix -one comes from the double bonded oxygen or ketone on the second carbon atom. Another organic compound in nail polish remover is butyl acetate. Butyl ethanoate is the IUPAC name. The general structure composes of an ester linked to another carbon on one side, while the other side has linked 4 carbons. Therefore, the compound gives you the IUPAC name of butyl ethanoate because of the 4 carbons on the right side that represent butyl, and the 2 carbons on the left side that represent the ethanoate because eth equals 2 carbons. The third organic compound that I found in nail polish remover is glycerin. The IUPAC name for this compound is 1,2,3-tripropanol. This is an alcohol. There are 3 carbons attached in an alkane linkage, thus giving the prop prefix and the ol suffix. The 3 alcohols in this compound are attached to the first, second, and third carbon atoms, which gives you the numbers at the beginning of the tri prefix added to the whole compound name. Here is a summary of all 3 organic compounds that I decided to analyze from the nail polish remover label. Acetone has a unique history. The compound has many layers in terms of the key people behind its discovery and the way it was used in previous centuries. Acetone was first produced by alchemists. During the late Middle Ages, acetone was discovered via the dry distillation of metal acetates like lead acetate. In 1832, a French chemist named Jean-Baptiste Dumas and a German chemist named Justus Lohn-Liebig discovered the chemical formula for acetone, which is C3H6O. In 1833, another French chemist named Antoine Bussy named acetone by adding the suffix -one to the stem of the acid acetic acid. Later, an English chemist named Alexander William Williamson realized that acetone was actually methyl acetyl, and later this idea was concurred. In 1865, a German chemist named August Kalki published the modern structure for acetone. Acetone was primarily used in the Middle Ages, and it was produced during this time as well. It was used in the 17th century for medical purposes. Schools of pharmacy in Paris would dry distill metal acetates and lead. Prior to World War I, the United Kingdom would use calcium acetate to create acetone, and calcium acetate is the calcium salt of acetic acid. With the outbreaks of war and an increase in demand for substances, there were many people who required acetone. The production of gunpowder was needed, and the main supply of calcium acetate was used during World War I. Similarly, during World War I, a method of producing acetone through bacterial fermentation using sugar was developed. Acetone is a volatile compound that can cause serious problems if it is not used with care. Acetone can be used to create plastics, acrylic products, and windows. These products require BPA, and BPA is in relation with acetone. When acetone is used as a solvent, it means that acetone dissolves with some other chemicals. Hazardous spills can be dissolved with solvents like acetone, for example, oil spills and gas spills. Acetone can also be used as a cleaning supply in the sense that it can be used as a solvent in glass cleaners. There are many physical properties associated with acetone. Some of the main physical properties of acetone are that it takes in a liquid form, it is transparent, has a sweetish odor, and it has a pungent taste. It is also soluble in water, alcohols, and other organic compounds, therefore showing that like dissolves like. It is also combustible, and it can undergo combustion reactions. Some numbers associated with acetone's physical properties are its melting point at -94.7 degrees Celsius, a boiling point at 56.05 degrees Celsius, and the density of the compound at 0.7845 at 20 degrees Celsius. Here is a quick summary of the key physical properties of acetone. Acetone is a molecule that has chemical, industrial, and biological significance. Chemically, it is the simplest and most important of the ketones functional group. Biologically, acetone is capable of dissolving many fats and cellulose ethers. Scientifically, acetone is used to manufacture fibers and explosives. In the healthcare sector, it can be used as a solvent for chemicals like vinyl. It is used in cosmetics as a key ingredient for nail polish removers, thus giving it a positive societal view. Overall, it is used to benefit humans in so many ways that it has no negative viewpoints and it has a good ethical standing point.